As you already saw in the first part of this series, the German physiologist Carl von Voigt determined the energy expenditure of the human body based on the assumption that nitrogen-containing substances are energy producers and that the nitrogen contained in the food eaten is equal to the nitrogen eliminated out of the body through urine and feces. Voigt began using the gram calorie in lectures on human energy balance and published extensively his studies in prominent German journals. He is considered today the father of modern dietetics, and his unit of heat was quickly embraced by the physiologists and dietitians of the period, who began using the small calorie in studies regarding the heat of combustion for food and the heat produced in respiration. Voigt was also interested in what way fat and carbohydrates were interchangeable in nutrition, and he calculated that 100 grams of fat were the physiologic equivalent of 175 grams of starch. Voigt's studies regarding macronutrients interchangeability were continued by one of his students, the German physiologist Max Rubner, who proposed that different foods may replace one another, providing the human body with the same amount of energy in accordance with their caloric value as determined when burned in a calorimeter. The setup used by Rubner to determine the energy value of different foodstuffs consisted of the following. The substance to be analyzed was placed inside a container where it was burned along with other materials furnishing oxygen. The container in which the substance was burning was placed inside another container filled with water. As the substance in the inner container was burning, the resulted heat was causing the water's temperature to rise, and the energy value of the analyzed substance was determined by measuring the difference in water's temperature. To determine how much energy different foods provide to the human body, Rubner deducted the heat value of urine and feces, which he associated with the latent heat of the body, from the value determined with the help of the calorimeter, and, after numerous experiments, he concluded that 100 grams of fat released the same amount of heat as 232 grams of starch, or 234 grams of cane sugar, or 243 grams of dried meat. He also concluded that casein, when burned in the calorimeter, has an energy value of 4.4 calories per gram. Meat indicated an energy value of 4.2 calories per gram, while vegetable protein, 3.9 calories per gram. Considering a mixed diet, Rubner averaged the values of casein, vegetable protein, and meat and set the energy value of protein at 4.1 calories per gram. Olive oil and animal tissue fat indicated an energy value of 9.3 calories per gram, while butter fat, 9.1 calories per gram. Thus, Rubner set the energy value for fat at 9.3 calories per gram. He applied the same principle for carbohydrates, and, because starch had an energy value of 4.1 calories per gram, sucrose 3.9 calories per gram, lactose 3.8 calories per gram, and glucose 3.6 calories per gram. Considering the predominance of starch in an average diet, Rubner set the value for carbohydrates at 4.1 calories per gram. These values were later rounded down to 4 calories per gram for protein, 9 calories per gram for fat, and 4 calories per gram for carbohydrates, are known today as the Atwater system or the 494 method for determining the energy value of foods and drinks, and were printed, in the 1990s, even on the first versions of the US Nutrition Facts label. However, as some quick observations regarding the energy value of macronutrients, Carl von Voigt realized that the energy value provided by a substance in the body is not the same as the value obtained when the same substance is burned in the calorimeter. In 1901, in his Necrology to Pettenkofer, Voigt wrote that the metabolism in the body is not proportional to the combustibility of the substances outside the body, but that protein, which burns with difficulty outside, metabolizes with the greatest ease than carbohydrates, while fat, which readily burns outside, is the most difficulty combustible in the organism. He was half right. The human body requires energy for everything it does, including swallowing, digesting, absorbing, and metabolizing food. This amount of energy is known today as specific dynamic action, diet-induced thermogenesis, or the thermic effect of food, and its magnitude varies with factors such as age, physical activity, meal frequency, regularity and timing, meal composition, and so on. It is generally believed that carbohydrates have a thermic effect of about 5 to 15%, protein 20 to 30%, while fat, at most 5 to 15%. Although modern scientists are still debating on the exact figures, all the studies showed that, contrary to what Voigt assumed, protein requires much more energy to metabolize than carbohydrates or fat. Thus, if we go with a thermic effect of, say, 10% for carbs, 25% for protein, and 5% for fat, 100 calories of carbohydrates, 100 calories of protein, and 100 calories of fat would end up in the body as 90, 75, and 95 calories of carbs, protein, and fat, respectively. However, back in the 19th century, Max Rubner disagreed with Voigt's conclusions, namely that the metabolism in the body is not proportional to the combustibility of the substances outside the body, and he argued that the exchange of energy predominates over the exchange of material. Rubner is known today for his isodynamic law of calories, according to which the form of human calorie intake is irrelevant to its effect on energy balance. Often paraphrased as a calorie is a calorie, this principle is widely debated even by modern nutritionists and dietitians. It is quite true that when burned in a calorimeter, carbohydrates have fewer calories than fat, but by this logic, a soda or a bag of candies is better than a glass of milk or a handful of nuts. Also, if we really think about it, the setup used for determining the energy value of macronutrients doesn't quite make sense because if we would dry out completely any food or drink, all there would be left would be the ash, which cannot be called food. Plus, without water, we wouldn't have any food or drinks in the first place. Nevertheless, this is why water is the only substance that has, indeed, 0 calories. Any other food or drink that can be burned in a calorimeter has an energy value, so don't get tricked by various claims found on food labels. And now, let's see how the gram calorie has become the favorite unit of energy in common speech and public nutrition education, without even being defined anywhere in the scientific nomenclature.